Hi, Algebra 2. This is a video of the homework answers for Unit 13, Lesson 4. So this is the normal distribution and z-scores. So you learned in this unit that the z-score is the number of standard deviations a piece of data is from the mean. The formula that we use, so the z-score, that's the z. So we take the data value that they give you minus the mean divided by that standard deviation. Okay, so that's a formula we're going to use for all of these problems in exercise 1. So you can see that they give us a mean. The population has a mean of 24.8 and a standard deviation of 4.2. So basically, that mean is going right here. So you can see that that is right here in every single problem. A, B, C, D, E, and F. Okay, and my standard deviation is 4.2. So my standard deviation is what I'm dividing by. So the 4.2 is on the bottom. The only thing that changes is that x value. So they're going to give us an x value in every single problem. I'm going to subtract the mean, and I'm going to divide by the standard deviation. So on A, my mean is 30, so 30 minus 24.8. Make sure that if you're using your calculator, there are parentheses around this. Otherwise, you can make sure that you hit, enter before you move on. But you would have to put parentheses around the 30 and the 24.8 and then divide by 4.2. Same thing in B. But anyway, let's look at the answer. So the answer I get is 1.24. If you get a positive number, then you're talking about a score that is above the mean. Okay, how many standard deviations? So basically, I'm 1.24 standard deviations above the mean. In B, my score was a 35. So again, I take my score, 35, subtract the mean, make sure that you have parentheses around all this, and you divide by your standard deviation. I got 2.43. So that score is 2.43 standard deviations from the mean. Okay, and again, it's above because it's positive. This next one, C, I get a negative number. So my score is 19. My mean is 24.8. So 19 minus 24.8 divided by 4.2 is negative 1.388. So I'm negative 1.38 standard deviations below the mean. D, my score was 15.4. So 15.4 minus 24.8 divided by 4.2. And that gives me negative 2.24. So I'm 2.24 standard deviations below the mean. E, you can see that my answer is 0, which makes perfect sense because my score was the mean. So 24.8 minus 24.8 is just 0. I don't care if you're dividing by 4.2, it's going to stay 0. And then F is, my score is 33.2 minus 24.8 divided by 4.2 gives me 2. So I'm 2 standard deviations above the mean. Okay. 2, a population has a mean of 102.8 and a standard deviation of 15.4. So this is my mean right here, 102.8. I'm still using my formula. My standard deviation, I'm dividing by my standard deviation. The difference is I don't have my score. That's what I'm trying to figure out. I actually have the z-score, but I don't have my data score right here. I don't have my x. But I still use that same formula. I know my z-score. My z-score equals x minus the mean divided by the standard deviation. So I put in my mean, I put in my standard deviation, I put in my z-score, I cross multiply right here, and 1.87 times 15.4 is 28.798 equals, and 1 times x is x, and 1 times 102.8 is 102.8. I'm solving for x, so I'm adding 102.8, and that's how I get 131.6. So this was using the same exact formula, except you know the z-score, and you were using it to solve for x. Okay, and then it says that they want us to practice with that normal distribution table and your calculator. I really just use the calculator on all of these. It's only that last one that last question, I think it was number 8, that I used the normal distribution table, and I made that one that you did not have to do. I wrote that down. You did not have to do that if you looked on the calendar. So we're just going to look at your calculator when you're doing these, all right? So every single one of these, we're using our calculator. A recent study found that the mean amount spent by individuals on a music service website was normally distributed with a mean of 384, a standard deviation of 48. Which of the following gives the proportion of the individuals that spend more than $400? So this is just like yesterday when we were doing that second VARS, or actually last week probably. So in your calculator, you're going to hit second VARS and then norm CDF. So that was number 2. This 400.1 is the lower, 1,000 is the upper, and my mean is 384, and my standard deviation is 48. So that all goes into your calculator. Depending on what calculator you have that you're using, depends on how you'll input this, but this is the lower number, the upper number, the mean, and the standard deviation. And I get 0.3694. So I rounded that off to 0.37. Same thing for number 4. The hold time experienced by people calling a government agency was found to be normally distributed with a mean of 12.4 and a standard deviation of 4.3. Which percent below represents the percent of calls answered in less than 5 minutes? So 5 is the upper because I want to be less than 5 minutes. So that's the upper number. My lower number, I just put in negative 1,000. If I don't have a lower number, if it's, infinite, although here I probably could have put in 0 because you can't have a negative number amount of minutes, but it won't change my answer at all. So my lower number is negative 1,000. My upper number is 4.9999 because I want to be less than 5 minutes. My mean is 12.4. And my standard deviation is 4.3. All that goes into my calculator, and I get 0.0426. Remember, I'm moving my decimal 2 places over, and that's why I have 4.3%. Okay, we just have a few more on the next page. So I told you in the calendar that you could skip 6 and 8. I have all the answers there, so if anybody did try them, you can look at them. Number 5 is just another calculator one. The national average price per gallon of gas is normally distributed with a mean of $2.34 and a standard deviation of 0.26 per gallon. Which of the following represents the proportion of the gas prices that lie between $2 and $3? So $2 is going to be my lower number, and you can see that I have that right here too. And $3 is going to be my upper number. My mean is 2.34. My standard deviation is 0.26. All of this goes into my calculator, second VARS, norm, CDF, and I get 0.8989. And I want this to be a percent, so I move my decimal 2 places, and that's going to be 90%. Okay. 6, I said you could skip. They talk about a quintile. A quintile is basically dividing this into fifths. So I was looking for the lower 20%. So again, I put all of those numbers in there, my lower, my upper, my mean, and my standard deviation, and I get 0.2329. So I really got 23%. That is not in the lowest quintile. But you did not have to do number 6. I just have that there in case anybody did try it. 7, the average rent for a 1-bedroom apartment in the winter of 2015 in New York City is a whopping $2,801 per month with a standard deviation of $920. If rents are normally distributed, so that's important that it says that, what percent of the apartments will be less than $2,500 per month? So again, I'm using my calculator, that's second VARS. I put 0 in here because you can't really have a rent that is negative, but it really does not matter. If you did this or we were always putting in negative 1,000, that would be fine. But 0 is my lower, 2,500 because I want to be less than that. My mean is 2,801, and my standard deviation is 920, and that gives me 0.37, which is 37%. Okay, so only 37% of the rents will be less than $2,500. If rents are normally distributed, how realistic is it to believe you will be able to rent a 1-bedroom apartment in New York City for less than $1,500 per month? So again, calculator, second VARS. 0 is my lower. I want to be less than $1,500, so 1,500. My mean is 2801, and my standard deviation is 920, and that gives me 0.077. I moved that decimal 2 places, and that's how they rounded that up to 8%. Okay, if you left it as 7.7%, that would be absolutely fine also. One-bedroom apartment on the Upper East Side with a doorman and views of Central Park was listed at $5,000 per month. How rare is this? Assume rents are normally distributed. So that's my lower number, 5,000. Okay, and my upper number, I just wrote 10,000. My mean is 2801, and my standard deviation is 920. If I put that in my calculator, I get 0.00841. So am I moving my decimal 2 places? It's really 0.8%. Okay, so very low to have a rent of 5,000 per month. Do you think the rents are normally distributed? Keep in mind the normal distribution is symmetric about its mean. Looks like the same on both sides. If it isn't symmetric, what does it look like? It could be normally distributed, but technically it could stretch out forever and ever. There is no upper limit to what the rent could be, but there is a lower limit, and that lower limit is 0. You can't have a rent of negative. Okay, but there's really no limit on the highest rent. So it could be normally distributed, but technically the right side could go out a little bit further than the left side does. Okay, and I said that you did not have to do 8, so you can stop the video right now if you didn't do it. If you did do it, I have a math competition advances to the second round. Only the top 5% of all participants based on the scores from a first round exam. Their scores are normally distributed, so it's important that it says that, with a mean of 76.2 and a standard deviation of 17.1. What score to the nearest whole number would be necessary to make it to the second round? To start, look at the table and see if you can determine the z-score that corresponds to the top 5%. So if I'm talking about the top 5%, I drew my little normal distribution right here. So 0.95 is everything in here that's shaded. But I'm going to subtract 0.5 because I don't really care about this. I'm caring about everything that is to the right of this mean. Okay, so if I'm 0.95 is the whole thing that's shaded, I subtract out 0.5 because this right here is 0.5. So I'm going to subtract that 0.5 out, and I'm left with 0.4500. So this is a number that I'm going to look at in that normal distribution table. I'm going to try and find that to find my z-score. So here's how I do that. I'm looking in my normal distribution table, and right here is 0.4495 and 0.4505. Remember, I was looking for 0.4500, so it's in between these two numbers. Well, what's the z-score? The z-score is 1.6, but then I have to look up here. It's 1.64, but it's in between 4 and 5, so 1.645. That's my z-score. So you use this table to find your z-score. If you know your z-score, you can find that standard deviation in there. So now that I know that it's 1.645, that's what I just looked up in the table, and I'm using my z-score formula. So the z-score, 1.645, equals the score x minus the mean, which I got from my problem, 76.2 right there, divided by 17.1. And all I do is I put a 1 under here, and I'm cross multiplying. 1.645 times 17.1 is 28.1295. And 1 times x minus 76.2 is x minus 76.2. I add 76.2 to this side, and I get 104. Okay, so that would be my answer.